Theoretical recap. In Linux, copying, moving, and deleting files are everyday operations, but in a security context, each action carries real risk. The commands cp, mv, and rm are powerful and unforgiving. There is no recycle bin, no undo, and no prompt by default. Understanding how to use them safely is not optional for a cybersecurity professional. CP copies a file or directory from a source to a destination. Without the R flag, it cannot copy directories. The P flag preserves permissions and timestamps, critical when copying sensitive files whose metadata must be maintained for forensic or audit purposes. MV moves or renames a file. It is atomic on the same file system, meaning it either succeeds completely or not at all, a property that matters when handling logs or evidence files. RM permanently deletes files. The R flag removes directories recursively. The I flag prompts before each deletion. Never run RMRF on an unknown or variable path, a classic and catastrophic mistake. Tools like shred or wipe exist specifically to overwrite file content before deletion, preventing recovery, essential when handling credentials, keys, or sensitive data. Common mistakes include overwriting a destination file without realizing it, deleting the wrong directory due to a typo or an unquoted variable, and assuming deleted files are unrecoverable. They are not. Without secure deletion. A solid mental model. Always verify your source and destination with ls or tree before executing destructive commands. Use I, interactive, flags during learning, and v, verbose, to confirm what is happening. Mini example, cprp/var/log/auth.log/backup/auth.log.bak preserves permissions while backing up an authentication log, a realistic security task. Workshop brief. This workshop puts into practice secure file manipulation in a Linux environment with a cybersecurity focus. You will work with sensitive context scenarios, log files, configuration files, credential placeholders, and evidence directories, to simulate the kind of file operations a DevSecOps or pen testing professional encounters regularly. The goal is not just to execute commands, but to demonstrate that you understand why each choice is made and what the consequences of mistakes would be. You will complete this workshop over a recommended duration of 3 hours. You must submit your solution before the deadline expires. You are fully authorized to consult all previous theoretical course chapters and any relevant online resources. You may work alone or seek help, but your written explanations and command choices must reflect your own understanding. Scenario and environment setup. Begin by setting up a controlled working environment in your Linux terminal. Create a root working directory called ~secops lab. Inside it, build the following structure using touch and make dar. A directory called log/containing 3 files, access.log, auth.log, error.log, a directory called config/containing 2 files, sshd_config, firewall_rules.conference, a directory called sensitive/containing 1 file, api_keys.txt, and an empty directory called archive/. Populate each file with a few lines of realistic-looking placeholder content using echo or a text editor. This step is intentional. You must work with files that have content, not empty ones. Once your structure is in place, document it with tree_secops lab and save the output. Copy operations with security awareness. Your first task is to back up the entire log/directory into archive/, preserving all file permissions and timestamps. Choose the appropriate CP flags and justify your choices in a short written note, 2 to 4 sentences. Next, copy only sshd_config from config/ into a new directory called configs_backup/, but this time intentionally omit the permission-preserving flag. Then, compare the metadata of the original and the copy using LSL. Document the differences and explain why this matters in a security or forensic context. Finally, attempt to copy the sensitive /directory without the recursive flag and observe the error. Note what happens and why. Move operations and renaming. Move error.log from log/ into archive/ and rename it to error.log.old in a single mv command. Verify the result. Then simulate a log rotation scenario. Move access.log to archive/access.log.$date plus %y%m%d, using command substitution to append today's date to the file name. Confirm the operation with lsl archive/. Reflect briefly. What would happen if you ran this mv command and a file with that exact name already existed in the destination? Test it and document the behavior. This is a realistic concern when automating log archiving in a DevSecOps pipeline. Secure deletion and data sanitization. This section focuses on the security-critical difference between deleting a file and securely erasing it. First, delete API_keys.txt from the sensitive/directory using RM. Then investigate, is the file truly gone? Use ls to confirm, but also research what forensic tools, such as strings or file carving utilities, could potentially do with the raw disk. You do not need to perform forensic recovery, just explain the risk in writing. Next, create a new file called temp_credentials.txt in sensitive/, write at least 3 lines of placeholder credential data into it, and then use the shred command to securely overwrite and delete it. Use the appropriate flags to overwrite multiple times and then remove the file. Document the exact command you used and explain what each flag does. If shred is not available on your system, research and use an equivalent tool or explain the manual alternative using DD. Finally, use rmre to interactively delete the entire config's backup/directory. Document the prompts you received and reflect on when interactive deletion is a good practice versus when it becomes a bottleneck. Reflection and submission. Prepare a single submission document, plain text, Markdown, or PDF, that includes the output of tree_SecOps lab taken at the end of the workshop, all commands you executed, copy them from your terminal history or note them as you go, your written justifications for each major decision, flag choices, method choices, observed behaviors, and your explanation of the secure deletion risk. Your document should demonstrate not just that you ran the commands, but that you understand the security implications of each operation. This reflective component is assessed as much as the technical execution itself. Review your work before submitting. Ask yourself, did I preserve metadata where it mattered? Did I understand what RM actually does to data? Could I explain to a colleague why shred is necessary when handling credential files? If you can answer these questions clearly, you are ready to submit.